Hi, and welcome to this video from the Algebra and Functions section, the Year 2 part of the course. And in the previous video, we had a look at the basics of simplifying fractions. We dealt with all this stuff. What we're going to do is now have a look at something called partial fractions. And essentially, all that partial fractions is about taking an algebraic fraction and splitting it apart. And we're going to start off by just looking at how we add two fractions together to get an understanding of what that will give us, and then that will enable us to go the opposite direction. So let's start off with a simple addition, or in this case, sorry, a subtraction. Let's face it, they are one and the same thing. So all I'm going to do is I've got to get a common denominator. My common denominator is going to come from the product of these two things. So what I'm going to do is write each fraction of this one here. I'm going to write as by multiplying by x plus 2 top and bottom. And this fraction here, I'm going to multiply top and bottom by 2x plus 1. That's the result we get. Paying close attention to the fact we've got a minus in there. There it is. There's the fact we dealt with the minus. Do the tidying up, and that's where we end up. Now, the reason that I've gone through that is to say, well, if I know that I can put two fractions together by subtracting and end up with something in this form, it means I know if I've got something in this form, I can essentially break them apart and write them like that. And being able to do that is going to be useful in some of the techniques we're going to be seeing later on, particularly when we're doing series expansions and particularly some integrating. Okay, so here we go. What I've got is a fraction here, and what we're going to do is split it apart and write it as two completely different fractions. And we know from the denominator that our new fraction is going to have these two as our new denominators, but what we need to figure out is what are the values that are going to go as part of the numerators, what are the values of a and b. So we're going to start off with a statement that says that this thing on the left is equivalent to, that's why we've got the three lines for the equal sign, the addition of these two fractions on the right for some values a and b. So now this is what's called an identity. We're saying that that's going to be true for certain values of a and b. We're going to try and figure out what those values are. And the first thing I'm going to do is just do a bit of rearranging of that identity. And we're going to multiply the entire thing by x plus 1, x minus 3, which is essentially this denominator here. So let's do that. We get that, and clearly what's going to, so we can see we've got, there it is on the left, there it is in my two fractions on the right, multiplied all three bits by the same thing. Now we can do a whole load of cancelling. Those disappear there. We've got the x plus 1's disappearing there, and the x minus 3's disappearing in the third part of it. And so we can see that this thing is clearly going to become a whole lot more simple. Now, this whole cancelling process, you don't actually need to show. When you see the next line, this is all you really need to come up with, and hopefully, as you get better at these, you'll be able to jump straight on to there. So you don't have to go and explicitly show all the cancelling. It's quite okay just to jump straight from this line here down to this one here. Right, so now that's a much more simple expression to it. We were saying that for some values for a and b, this addition on this right side is going to have a value of 4. So we just got to figure out what those values are. And the easiest way to do that is just to pick certain values for x and see what happens. So what we're going to do is we're going to pick x equals 3. And the reason I'm doing that is because what that does is makes this thing here 0. So when x equals 3, what we get is 4 on the left hand side is the same as on the right hand side over here, 4b. So that means that b is going to have to be equal to 1. Now you might be thinking, well, what about other values? Well, the whole point of this identity here is this sign here means that this will work for certain values for a and b, but it will work for every single possible value of x. So it's quite okay just to pick a random value of x, and it makes sense to pick ones that makes our life easier and enable us to find out what these values for a and b are going to work out to be. So that's why it's okay to just chuck that x equals 3 in there. Now, the next thing we're going to do is figure out what a is, and clearly I'm going to do that by picking a value that makes this thing here 0. So I'm going to pick x equal to minus 1, and again put that into my identity. So I've got 4 equals, and if we put minus 1 in here, we're going to get minus 4. We put minus 1 in there, that makes that 0. So I'm just looking at this bit now, so it becomes minus 4a. So we've got a equals minus 1. And so therefore my partial fraction, this fraction here, can be written as x minus 3 take away x plus 1. So what we've done is split that fraction into its two separate parts. Right, that was a fairly straightforward example. Let's go and make life, as ever, a little bit more complicated. So we've got two fractions there. First one we're going to look at is this one here. Now hopefully we're looking at the bottom of that thinking, well, that looks like we can do something with it. And clearly hopefully you've spotted that that thing there is different to two squares. So first thing I'm going to do is factorise it. And so what that means is I can write this thing as an addition or subtraction of two fractions, and my two fractions will look like that, 4 plus x and 4 minus x. Same principle as before. What I'm going to do is do the multiplying through to create a new version of my identity. And again, you can see, if you imagine taking this thing over to this side, it's the 4 plus x part that's going to cancel here, leaving us with the 4 minus x. It's the 4 minus x part here that's going to cancel, leaving the 4 plus x bit there. So just take a moment just to make sure you're happy with all the multiplying out and cancelling that I've done. And now we're going to pick some values for x, and the first one we're going to go for is going to make a 0. So I have to try again. So they're going to make this bracket 0. So we're going to pick x equals 4. And if we make x equals 4, that whole thing becomes 0. That bit there becomes 8. And over here, if I've got x equals 4, then I've got 5 times 4, which is 20, plus 36, that's 56. And over on this side, I've got 8b. And that gives me that b is 7. And then if we let x equal minus 4, that's bit that's going to make that whole thing disappear. This bit here is now got to be careful. So I've got 4 minus minus 4. So that's going to become 8a. And over here I've got minus 20 plus 36. So that's going to be 16 equals 8a. So we've got a equals 2. And there we go. There's our fraction. Becoming 2 over 4 plus x plus 7 over 4 minus x. Nice things with these things, if you wanted to, you could always check that it works out, because all you've got to do is just do the adding again and prove that on your denominator you get back to the 5x plus 36. So it's fairly easy to check them. Right, on we go to part B. This one's a little bit more complicated because we've got 3 factors on the bottom here, but essentially you might have guessed at what's going to happen here. All I'm going to do is split this out into 3 rather than 2 fractions. So there we go. And again, do the multiplying out. If I multiply out by x, x minus 1, 1 minus 2x, it's the x that's going to cancel there, leaving me with x minus 1, 1 minus 2x. In the middle here, the x minus 1 is going to cancel, leaving me x bracket 1 minus 2x. And over here, I'm going to be left with x bracket x minus 1. So that's what you end up with. And again, all we're going to do now is pick suitable values for x. So I'm going to start off by letting x equals 1. Now again, what's going to happen is that bracket there is going to be 0, so this bit's going to disappear. And also, this one here is going to be 0, so I'm just going to be left with what I get from this section here. And over on this side, I've got 2 minus 3 minus 4, which is minus 5. And on the right-hand side, that bit there is just coming from x is 1, so I've got 1 times by 1 minus 2. That bit there is going to be minus 1. So I've got 1 times minus 1, hence this is just minus b. Clearly that gives me b equals 5. Next thing I'm going to do is let's let x equal 0. And that means this bit's going to disappear. It means this bit's going to disappear. On the left-hand side, I've just got 2. And on the right-hand side, if x is 0, that bracket is minus 1. That bracket is 1. So I've just got minus a. So that gives me a equals minus 2. And finally, I'm going to pick x equals a half, because that's going to make that bracket there 0, that bracket there is going to be 0, so all of that stuff's going to disappear, just leave me with the c that I'm still looking for. So when we put x equals a half into the left-hand side, we get minus a half, and on the right-hand side, we end up equals minus a quarter c, and so that therefore gives us c equals positive 2. Okay, so there's our 3 values, so that means that our partial fraction is just going to be minus 2 over x plus 5 over x minus 1 plus 1 plus 2 over 1 minus 2x. And there it is. There's our fraction split into the 3 separate bits. Jobs are good.